Okay, Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Today we are going to discuss two more partial question, which is question 13 and question 14 for chapter reaction kinetic. Alright, on the screen, on heating dinitrogen pentoxide N2O5 decomposes as follow. So the equation are given. The reaction is first order with respect to N2O5. Number 1. Determine the rate of formation of O2 if the rate of disappearance of N2O5 is 1.25 exponent negative 2 molar per minute. So for this question, what we need to do is the differential equation first. So rate equal to negative 1 over 2 dN2O5 equal to positive 1 over 4 dNO2 over dt equal to positive dO2 over dt. Okay. Then what we need to do is we just compare between oxygen and N2O5 because those are the only two requested in the questions. Okay. So we need is, so this is number 1, dO2 over dt equal to 1 over 2 in bracket negative dN2O5 over dt. Okay, I do it like this because rate of disappearance of N2O5 1.25 ni. So this one, this part is actually written as negative dN2O5 over dt. So we just substitute the value. So 1 over 2 times with 1.25 exponent negative 2. And the answer should be 1.25 divided by 2. 6.25 exponent negative 3. Okay. Unit depends on our 1.25 unit. So molar per minute given in the question. So this one also molarity per minute. So that is for question 1. Okay, next look at question 2. Calculate the rate constant for this reaction if 25% of N2O5 is decomposes within 10 minutes. Okay, so 25% of N2O5 is already converted into product. So the remaining concentration of N2O5 should be 100 minus. So N2O5 initial is equal to 100%. Therefore, N2O5 final will be 100 minus 25. We get 75%. And the formula for first order is ln N2O5 initial minus ln N2O5 equal to KT. So substitute the value. So 100 minus ln 75. K, we need to find out T. I think the question say 10 minutes. Okay. So K equal to So 2.228788 exponent negative 2 unit minute minus 1. Why minute? Sebab atas tadi minit kan? Ini dalam minit. Right? So that is for question number 2. Next, question number 3. Determine the half-life for this reaction. Okay. Number 3, half-life. So the formula for half-life of first order is T half equal to ln 2 divided by K, rate constant. So ln 2 divided by, mana kita punya K? Oh tadi 2.88 exponent negative 2, and our final answer will be ln 2 divided by 2.88 exponent negative 2, 24.07 minutes. Okay, so that is the answer for question number 13A. Itu sajalah. Right. Next, let's proceed with question number 13B. 13B. And alright. Okay, so question number 13B, table 1 shows the rate constant for the decomposition of N2O5 at two different temperature. Okay, dia bagi dua nilai temperature, dua nilai rate constant S-1. Determine the activation energy for this reaction in kilojoule per mole. Number 2, activation energy can also be determined graphically. Sketch the graph and explain briefly. Number 1. So we have two different temperature, two different rate constants. So the formula should be ln K1 over K2. Ln K1 over K2 equal to EA over R in bracket 1 over T2 minus 1 over T1. Okay. So remember, for this formula, R is equal to 8.314 joule per mole per Kelvin. So because of this is Kelvin, all this temperature, you must convert into Kelvin. So plus 273.15 for each. Right, so kita substitute ln K1. So let's say the top one is 1, the bottom is 2. So K1 1.74 exponent negative 5 divided by 6.61 exponent negative 5 equal to EA, we need to calculate, R 8.314 in bracket 1 over T2 35 plus 273 308 308.15 minus 1 over 25 is 298.15. Then EA will be so what I get is 101,502.96 roughly joule per mole. Okay, so the question asked in kilojoule, so kita kena divide by 1000, so 101.503 roughly kilojoule per mole. Right. So that is for question B1. Next, let's look at question number 2. It says the activation energy can also be determined by graph. Sketch the graph and explain briefly. Right, number 2. Okay, so if we are plotting a graph, we should use the formula of, okay, the original of this equation is A equal to sorry, wrong. Rate constant K equal to Arrhenius constant exponent negative EA divided by RT. So after we learn both sides, we will get ln K equal to negative EA over R in bracket 1 over T plus ln A. So this one already mentioned in your lecture notes. So from this, what we should plot is ln K as our Y, 1 over T as our X. So negative EA over R will be our negative M, and ln A is our intercept C. Alright, mana pen hitam, right? So our graph will look something like this. So y-axis is ln K, x-axis 1 over T, make sure unit in Kelvin. Okay, and then we will get our graph straight line with negative slope. The intercept here will be ln A. Then how do we calculate the EA? So EA equal to our gradient. Okay, so negative M, our gradient equal to negative EA over R. So we can cancel out this part. So EA is equal to our gradient times with gas constant R. That's it. Itu sahaja untuk question number 13B. Right. Okay, Assalamualaikum warahmatullahi wabarakatuh. Jom kita sambung ke question number 14. Right. So question number 14 says the data for the relation between metal ethanoate with hydroxide ion is shown in table 1. So kat sini saya ada buat pembetulan pada soalan. Dia sedikit typo 0.0 point, dari double point kat situ. It should be 0.084. Itu sahaja. Alright. So the first question, determine the order of reaction with respect to each reactant. So kita kena guna cara yang bahagi-bahagi tu. Eksperimen 2 dibuat by eksperimen 1 ke, depends on kita punya data. Right. So let's look at our data. So the first part, 0.05 is similar to 0.05 sama. Option 1 or option 2, 0.084 and 0.084. So yang ni saya tukar later. Choose purple. Right. So to get the order of reactant, the order of reaction for reactant OH minus, so you can choose either between experiment 2 and 1 or between experiment 3 and 4. However, to get the order of reaction for reactant CH3COOCH3, you only have one option, which is experiment 2 and experiment 3. Yes, itu je OH yang sama. So kita start dengan dapatkan nilai CH3COOCH3 dulu. Kita guna yang tu dulu, dapatkan nilai OH minus dulu. Manalah. Right. So I choose experiment 2 and experiment 1. So saya start with the rate law. Rate law, general rate equal to K, concentration of CH3COO CH3 power of M times with OH minus power of N. So that's the general rate law. Then the experiment 2 divided by experiment 1. So the rate for experiment 2 is 2.03 exponent negative 3 divided by rate for experiment 1 is 1.58 exponent negative 3 equal to rate constant, concentration of CH3 0.05 power of n times OH minus 0.154 n divided by rate constant K 0.05 power of n times n 0.12 of n. K and K cancel out, 0.05 power of m cancel out with 0.05 power of m, so the remaining 2.03 divided by 1.58. So this one we get 1.2848285 roughly, equal to 0.154 divided by 0.12, so 1.283 power of n. So ini hampir sama, so conclusion n is equal to 1. Therefore, order of reaction with respect to OH minus is first order, or any other sentences that carries the same meaning as this is acceptable. Right, so OH minus dah settle, kita nak cari CH3COOCH3, so we have no other option except for this experiment 2 and experiment 3. Okay, so this part I'm gonna use experiment 3 divided by experiment 2. Rate for experiment 3 is 3.4 exponent negative 3 divided by experiment 2, 2.03 exponent negative 3 equal to rate constant. CH3 is 0.084 power of n and 0.154 power of 1. Kenapa satu? Sebab tadi dia dah dapat dah first order. Ganti je. Divide by K CH3 0.05 power of n times weight 0.154 power of 1. Okay, K and K cancel out. 0.154 power 1, 0.154 cancel out. So 3.4 divided by 2.03. So this one we get about 1.675 equal to 0.084 divided by 0.05. 1.68 power of m. So again the number are about similar. So m is also 1. Therefore order of reaction with respect to CH3 COOCH3 is first order. Alright. So first order for both of the reactant. So that is for question number 1. Next, question number 2. The question asks for write the rate law for the reaction. So rate law. Okay. So di jawapan rate equal to K concentration of CH3COOCH3 times weight concentration of OH minus. Since both are power of 1, so tak tulis pun tak apa. So the power of 1 is not necessary. Next, question number 3. Number 3, calculate the rate constant. So rate constant, rate constant K. So to find nilai K, to find the value of K based on the rate law. Gunakan rate law yang tadi tu. Okay. So you can choose any values from any experiment. Just make sure you choose. If you choose one experiment 1, then you take all the values from experiment 1. Okay. You cannot mix. Example, rate you taken from experiment 1. The concentration CH3, COO, CH3 you taken from experiment 2. Then OH minus from experiment 3. Itu tak boleh. Itu adalah benda yang salah. If you want to take the values, just choose one experiment and then all the values are taken from that experiment. So for example, in this part, I'm going to use the values from experiment 4. You can try experiment 1 to 3, then you can compare your answer with my answer lah. Right. So for experiment 4, the rate is 4.42. 4.42 exponent negative 3 equal to K. We need to find out concentration CH3 is 0.084 times with OH minus 0.2. So K equal to 4.42 exponent negative 3 divided by 0.084 times 0.2. So 0.084 263. Okay. So that is the value. Then how about the unit? Unit tak tahu. Okay. So just compare kita punya nilai ni. Okay. So let's say I rewrite again the rate law. So kat atas. Rate equal to K concentration of CH3COO CH3 times with OH minus. Okay. Unit for rate given in the table. Okay, we look at the table again. In the table, rate given as molarity per second. Okay. So this is molarity S minus 1. K yang kita nak cari punya nilai. Okay. Concentration, molarity times with OH minus also molarity. So the unit of K equal to molarity second minus 1 divided by molarity times with molarity. So M cancel out with M. So you will be left with molarity minus 1 second minus 1. Right? So you can substitute this value, so this wording unit to molarity second minus 1. That's it. Okay, so that is for question number 3. Last one, question number 4. Apa dia? How many times will the rate increase if the concentrations of both CH3, COO, CH3 and OH minus are double? So, kita tinggal kat sini. And OH minus are double. Right. So, sekejap tengah fikir. Using rate law. So, rate equal to rate constant CH3 COO CH3 times with OH minus. Okay, since this part is long, so saya nak permudahkan. Kita kata let CH3COO CH3 equal to A and concentration OH minus equal to B. Okay, so now I can write as rate 1 yang pertama equal to rate constant times A times B. And then the condition, how many times will the rate increase if the concentration of both reactant are double. So dia soalan minta kita doublekan concentration, then find out how many times will the rate increase. So kita tambahkan dekat sini dia punya condition. If concentration A is double, so it will become 2A. Okay. Then if concentration B double, then it will become 2B. 2 kali B lah. So now we can write the rate law for the rate 2. Okay. So rate 2 meaning after we double the concentration. So rate equal to K times 2A times 2B. So kita buat keluarkan 2 tu, kita teruskan kat depan. So dia akan jadi 4K times concentration A times concentration B. So this is rate 2. Okay. Then if you notice this part here, sama dengan atas. Rate 1 equal to KAB. So K times A times B equal to rate 1. So now we can write rate 2 is 4 times rate 1. Dah dapat jawapan kan? So how many times? Plus pula 4. So 4 times faster ataupun increase by 4 times. How many times will the rate increase? Jawapannya 4 times. Okay, so that is for question number 14A. Now we look at question number 14B. The decomposition of ammonia to N2 and H2 at 450 degrees Celsius was studied and on the surface of tungsten and osmium as catalyst. The profile diagram for the reaction for each catalyst is given in figure 1. So this is the catalyst, the diagram, energy profile diagram. The process seems to be endothermic, sebab produk lebih tinggi. So which catalyst is better for this reaction? Explain. So which one is better? Just compare the EA, activation energy. The shorter one meaning the reaction occur very fast, less time needed. Longer EA meaning it requires more energy, so it will consume more time lah. It will take a bit longer for it to finish. So number 1. Number 1, which catalyst is better? The answer is tungsten. Why? Because the activation energy EA you need to spell out. Saya boleh shortcut. Difference kan? Okay. Nanti exam ni you need to spell out. Activation energy EA of apa tu dia? Activation energy with tungsten catalyst is lower than the activation energy with osmium. Osmium catalyst. Settle. So that is for question number 1. Question number 2. The activation energy for the above reaction using tungsten is 163 kJ per mole. How many times faster? Again, dia tanya how many times faster is the reaction if the temperature increase to 550 degrees Celsius. So what are the initial temperature? Boleh? Initial temperature is 450 degrees Celsius. The final one 550. Okay, kita list out the information. K1 rate constant, don't know. We have no values. So leave it as K1. T1 given just now is 450 degrees Celsius. So when converted into Kelvin, it will be 450 plus 273.15 723.15 Kelvin. Okay, K2 also we have no value, so leave it as K2. T2 will be 550 degrees Celsius. So in Kelvin 550 plus 273.15, we get 823.15 Kelvin. So given the EA, in the equation is 163 kilojoule per mole. So in joule 163 times 3 exponent 3 joule per mole. Kenapa dalam unit joule? Sebab R dia R 8.314 joule mole minus 1 Kelvin minus 1. That's why saya tukar unit semuanya dalam unit joule dengan Kelvin. Yes. So ada K1, ada T1, K2, T2, kita guna ln. Ln in bracket K1 divided by K2 equal to EA 163 exponent 3 divided by R 8.314 times 1 over T2 823.15 minus 1 over T1 723.15. Okay, siapa yang lupa formula boleh dah buka nota ataupun check balik previous question. Kita dah buat formula ni banyak kali dah. So saya tak tulis kat sini. So answer for K1 divided by K2 will be 163 exponent 3 divided by 8.314 times 1 over 8.314 minus 1 over 73.1 and then shift ln answer. So just now for this part you get 0.03712. So this one is the ratio between K1 and K2. So basically 0.03712 divided by 1. Okay, right. So in this part, 0.03712 is for K1 and the value of 1 is for K2. So how many times does the rate increase? So kita kena terbalikkan. Jadi K2 divided by K1. So 1 divided by 0.03712 is equal to 0.03712 equal to 26.9. So more or less is 27. Okay, so the answer should be 27 times faster. Jom kita semak. So this one kita nak check. Okay. Since K1 kita adalah 0.037, so bila kita check should be K1 times with 27, we should get the value of K2. Kita try. K1 0.03712 times with 27. So dia meningkat sebanyak 27 kali ganda. We should get 0.03712 times with 27. Kita dapat 1.00224. So more or less satu lah. So betul lah yang kita buat tu. Alright. So the conclusion is how many times faster? So the reaction increase 27 times faster. Right. So that is the final answer for question number 14B2. And that is all for question 14, and this is the end for past year question of reaction kinetics. Bye.